Space travel, once a distant dream, now closer than ever. And leading the charge? SpaceX. What if I told you that SpaceX has achieved something that was once thought impossible? Rockets that don't just launch into space, but come back and land, ready to be used again. A reusable rocket sounds like science fiction, right? Well, it's real. And today, we're breaking down exactly how these groundbreaking rockets work, focusing on one of the most incredible feats in modern engineering, their ability to land. Let's rewind for a moment. Traditional rockets have been around for decades, but they all had one huge flaw: once they were launched, that was it. They couldn't be reused. Imagine if every time you drove your car, you had to throw it away afterward. Crazy, right? The cost of constantly building new rockets was astronomical, literally billions of dollars with every mission. But SpaceX, led by the visionary Elon Musk, had a different idea. What if we could design rockets that could fly up to space and come back safely to be used again? This breakthrough would revolutionize space travel, making it not just more affordable, but sustainable for the future. And so, the Falcon 9 rocket was born. This is the hero of our story. But what makes it so special? The key lies in how it's built and its ability to land after a mission. The Falcon 9 is designed to return to Earth and land, often on a drone ship in the middle of the ocean. Other times, at a specific point on dry land. Sounds easy? Well, it's anything but. So, how does the Falcon 9 manage to do what no other rocket could? It all starts with its design. Falcon 9's first stage incorporates 9 Merlin engines and aluminum-lithium alloy tanks containing liquid oxygen and rocket-grade kerosene, RP-1, propellant. Falcon 9 generates more than 1.7 million pounds of thrust at sea level. The 9 Merlin engines on the first stage are gradually throttled near the end of first stage flight to limit launch vehicle acceleration as the rocket's mass decreases with the burning of fuel. These engines are also used to reorient the first stage prior to reentry and to decelerate the vehicle for landing. First, the rocket is built in stages. The most important stage for landing is the first stage, the part that gives the rocket its initial thrust to escape Earth's gravity. After it uses up its fuel and the second stage takes over, it's time for something extraordinary to happen: stage separation. The Falcon 9 uses several key steps to make this happen. The first stage detaches and begins its journey back to Earth, but now comes the tricky part: guiding a massive rocket, falling at over 4,000 miles per hour, safely back to the ground. As the first stage begins to fall, it's not just plummeting back uncontrollably. SpaceX engineers equipped the rocket with cold gas thrusters and grid fins, essential for guiding and controlling its descent. These allow the rocket to maintain stability and adjust its position as it falls. Now, the rocket is coming down, but at this point, it's still going way too fast to land safely. Here comes the reentry burn. The Falcon 9 reignites its engines again, but this time, to slow itself down as it re-enters Earth's atmosphere. Finally, the last phase, the landing burn. This is the final and most critical moment. The engines fire once more, slowing the rocket to a near stop just before touching down. They need to be turned on at the right time. If they are turned on beforehand, the vertical speed will reach zero before it reaches the ground, causing it to rise again. However, if they are turned on at the correct moment, the propellant will reach the ground with a lot of vertical speed, leading to an explosive impact. But when the engines are started at the perfect time, the rocket lands gracefully on its landing legs, ready to be refurbished and flown again. A feat that not only saves money but pushes humanity one step closer to affordable space travel. Now, how about we follow this entire process by watching SpaceX's Falcon 9 from takeoff to landing?
3, 2, 1. Liftoff of the Falcon 9.
Vehicles pitching downrange.
Stage 1 prop is nominal. Stage 1 entry startup. Stage 1 is transonic. Stage 1 landing we're in startup. Stage 1 landing leg deploying.
Falcon 9 has landed.
But why is this so important? In the past, space missions were incredibly expensive because rockets could only be used once. With reusability, SpaceX has drastically reduced the cost of sending things, and people, into space. Reusable rockets, like the Falcon 9, are more than just a technological marvel. They represent a fundamental shift in how we explore space, making it more affordable, more frequent, and more sustainable. This opens the door to incredible possibilities: space tourism, interplanetary colonization, and scientific advancements that can shape the future of humanity. Space travel is no longer just about going up. It's about coming back, and SpaceX has shown us how. With reusable rockets, SpaceX isn't just launching spacecraft, they're launching the future. Thanks for joining us on this incredible journey through the technology of the future. Make sure to hit that like button and subscribe to How Stuff Works HQ to stay updated on the latest in space technology, innovation, and beyond.